Imagine this is hypothetical molecule, the central carbon to which four different groups are attached, A, B, C and D. Now this molecule, if you want to see the mirror image of this molecule, if you want to see this molecule in the mirror, how would this looks? This will look like this. Now this is mirror image of this molecule. Now why we are studying this mirror image? Because this is playing a very important role in stereochemistry, in drug action. And stereochemistry and drug action is related with three-dimensional structures. For our understanding, we are drawing these molecules in the form of this, like these structures in the formulas, but actually molecule exist in three-dimensional world. So we need required to understand now this uh, stereochemistry is playing very important role. Research is based on this, so we have to understand what is this stereochemistry. Here we will going to see how this molecule, these two molecule looks. If you see this central carbon to which four different groups are attached, we can take one example of a model. This is a model, central carbon to which 1, 2, 3 and 4 different groups are attached. So this is one chiral compound. This is model. You can say that this molecule is present in this form. This is model, and if this is the model, then if you see this same compound, same groups, red, blue, yellow and white. Now if you see like this, you can say that this is mirror images of each other, exactly similar, as if you have kept mirror here, and this is mirror you are seeing of molecule. This is the same molecule, and if you see the groups are not changing, their bonding is not changing, therefore their physical and chemical properties are not changing. So enantiomers are the non-superimposable mirror images of each other. These are enantiomers. Now what is this non-superimposable? Non-superimposable means that if you try to superimpose one molecule on the another, you will not find all the groups of similar kind. Yellow similar, green, red not similar, this not similar, white similar. So you cannot, by doing any rotation or anything, it is possible you to have similar group on the all the sides. There is always some discrepancies. If you see this is not happening. This is, say, yellow, red, but here it is white, this side white and blue, so this is not happening. The point is that even though these are two same molecule, the molecules, these are same compound, similar physical and chemical properties, but they are mirror images, they are not superimposable. Now what is the significance of this non-superimposability? We have to understand that with respect to something, and in case of, say, in case of drug chemistry, drugs bind to the receptor and therefore the action is seen. This is the basic principle. Now imagine for a while that this is a drug molecule. This is a drug molecule means of same compound, but just stereochemistry is different of this compound and this compound, but they are, same physically and chemically. So this is one isomer, this is second isomer, enantiomer. This is pair of enantiomer. Then understand this, say that this is a receptor surface, this is a green area matching, so bond is forming here it is white, bond is formed, and here is red, bond is formed. Now this molecule is exactly matching on the places present on the receptor, and therefore this drug molecule will show its effect in the form of pharmacological effect. Now this molecule, which is exact copy of this molecule, mirror image, let's me try whether this also can be matched. Here it is green, so green matched white. No, here is red, here is white, not matching. So what can we turn? So I can turn this, I can keep white here, then here coming green, but red is here. Oh, it's not possible, it is not matching. So point is that even though they are exactly copy, but it is not possible here match exactly same color on the receptor by this molecule. Therefore, if these are stereoisomer enantiomers of a molecule, these may show pharmacological activity, whereas this may be inactive or may show adverse reaction. We call that side effects. So point is that the enantiomers are non-superimposable on each other, and they are very important when it comes to the bond. Some cases their position, their bonding required in a specific direction, and we can understand with this model that one isomer is exactly binding, another is not. So this is enantiomer, their importance. Then the thing is, if this molecule is somewhat, say, complex, and this is not that complex but somewhat as compared to first case. Now this is also model, 3D model. If you see this model, the carbon to which 3 groups are attached, the fourth here, the 4 valency of carbon, these two the same. If we see this molecule this way, we can understand that molecule, how it looks. All bonds are away from each other. This is known as staggered conformation, and this bond is, because it is single bond, it can rotate. Here this is the position where the groups are overlapping on each other. This is eclipse conformation. So point is that there are two important conformation: staggered conformation where the groups are away from each other, and eclipse conformation where groups are overlapping on each other. In between there are various forms of gauge conformation. Yes, this is staggered, this is gauge conformation, this is eclipse conformation. The conformation eclipse is more stable because the groups are far away from each other, potential energy is less, whereas the eclipse conformation is less stable because the groups are on the line of each other. There is great repulsion, steric hindrance, repulsion, sorry. So this is somewhat unstable state. Now this is happening because of rotation of this single bond. So this kind of isomerism observed in this kind of molecules where there is possibility of rotation of bond.